Hey guys, welcome back to a new video. So let me change my view. Yep. So today's question is minimum window substring. We have solved all these much of questions. You can go to my channel like this and yep, and then click on videos to get all these videos. I have solved these much of videos. You can definitely check there. So let me close this. Yep, today we are going to solve this minimum window substring problem. I have already opened this is a pretty hard problem. Yeah, and given two strings s and t of length m and n respectively, return the minimum window substring of s that such that every character in this including duplicates is included in the window. If there is no such substring, return the empty strings. Yeah, basically this is the question and the description says that the answer is unique. Okay, so we are going to get the answer as unique. Okay, so yeah, for example, here this is the S string and this is the ABC. So we have to check any window that contains ABC. So here this A, B, and C. So this window contains ABC, but this is not the answer because we have to find the minimum window, as you can see here. So if we can see it properly here, so this is the minimum window where A, B, C all three are present. They can be in any order and there can be multiple characters aside them. So yeah, but we have to find such many minimum window where all these character present in T are present. So this is basically this is the question. Let's see the approach first. So I have already added these things. So this is S and T. This is pretty much given in the problem. Here S frequency and T frequency is two maps. So T frequency maps, as the name suggests, have these map to these characters. So A is 1. So we will build using this in the code. We will see in the code. So A is 1, B is 1, C is 1. So this is a one-time process. We will calculate this map. So now based on this map, we will calculate the need. So need and will be two variables. Need will tell us we need three unique these characters in our S frequency map. So need the length of three is because we have like three characters in the map. So A, B, and C. So that's why this is three. Have will be so the current in the current window which we are going to see here. Then these how much these characters are present. So let me just start with this. So currently this is the one pointer and this is the another pointer. So this will be left pointer and this is the right pointer. So we will just move our right pointer. So firstly this is the first character. So we will add this here. Let me add this here. So A is 1. Now if this A is present in this T, this character A is present in this map, then we will increase our have. So it is present in the map, so we will increase this to 1. Now we will move this to the next. Okay, this is not moving. Let me try another window quickly. Okay, I have this. So now we are in the second character here. Okay. Why these are not moving? Let me quickly fix this. Okay, this is deleted. Yeah, we can move this. Let me quickly delete this as well. Let me add another one. Yep. So yeah, let me move this to the next value. Now the next value is D, and D is let me just increase the value corresponding to D here. So D is 1. Now D is not present here, so we will not update our have. So we will move to the next value, that is O. So O is let me just update the map. So O O is 1. O is not present in this, so we will not update this. Then we will move to the next character B. So let me just update B's frequency in S. So yeah, B is present here, so we will update this to 2. Okay. Now again we will move to the next this window, and we will again uh, just so corresponding E value will be like this 1, and E is not present in this map, so we will not increase this. So now we will C is present here, so now let me write 1 corresponding to C. C is present here in this map, so we will increase the uh, this have value. Now just try to focus here. Need is equals to have. So whenever this happens, we will update our window size. So now the window size is 1, 2, 3, 4, 5, 6. So the window size is 6, and the word is like this. So let me just quickly write the current word here, or let me just write these indices. So okay, let me write the indices here. So in this start index is 0, and 1 2 3 4 5 0 1 2 3 4 5. So end index is 5. So this is the current minimum window we find till now, from till here. So once we find this, we will move this left this pointer till the this have value is not equals to the need value. So yeah, so what we will do is we will just move this. Okay, not this, just this. So if we move this too, then we will also decrease the corresponding value here. So this will become 0, and if we are removing this A, so we have decreased this have also. So yeah, it will become, now it is not become 2, so we will again start increasing our this value, this pointer. So we will move this pointer now to the next value, and again do the same process like this. So let me just fast forward it. So we will do this, you are going to definitely do in a paper or pen. Just take a paper and do this for yourself. I just fast forwarded and move this window. Let me move this window to, why it's just not moving. Okay, it's not moving. So just see, let me just write here myself. So the window at the last will become this. So this will be the left value, and this will become the right value. So this will be like 0 1 2 3 4 5 6 7 8 9. So this is 9. We will get 9 here, and 10 11 12. So this will get 12 here. So we will at the very last we will get this minimum window. So we will update our this left position and the start position and the length, or the right position, whatever we want to do. We just update these whenever we find have equals to need. So we want the minimum window. If the window size is smaller than the previous calculated window, we will update these. So in this way, we will at the end we will find the minimum window. So let me just quickly tell you the code, show you the code. So it's a very lengthy code. I have already written it. Just try to focus on this code. So as I told you, so this is the base case. This is pretty simple. If it is empty, so we will return empty. There will be no possibility. So n is the size of the s string and m is the size of the t string. We will have two map, s frequency and t frequency, as I told you, s frequency and t frequency. We will initialize the t frequency map, as I told you here. We will iterate over this t string, and we will update this map. So yeah, it will get initialized, and have will be initially 0, as I told you here. Have will be initially 0, and need will be the unique values in this map. So unique values are, number of unique values are 1 2 3, so the size of this map. So yeah, so we will calculate the size of this map here. Start I will tell you later, so just skip for this now, and rest length also skip for now. So this is the left pointer, as I told you. This was this left pointer, and this is the right pointer. So left pointer initializes with 0, right also start with 0 and move to the length of the s string. So yeah, what we are doing now, what we are doing is we are fetching the character. We are increasing the frequency, as I done here. We fetch the character, like initially we fetch a, then we increase the frequency here, like similarly we are doing here, increase the frequency. Then we are checking if it is present in this, if this character is present in the t map. So we are checking if, and also the frequency is equal to the frequency in the t map, then we will increase the have. So same way what we do, we, if the frequency is also equal, if it is present in the, then we increase the have. So this is pretty simple till now here. Now this is the main logic here. Have equals to need. So I told you when the have become need, what we do is we calculate our L value or the start value and the length of the window. So L value is this, and the length of the window is 1 2 3 4. So initially we L value was 0, and the length of the window was 1 2 3 4 5 6. So this substring will do is it takes the starting position and the length to calculate to fetch out the substring. So yeah, so that's why we are maintaining the start and the res length. Whenever the window size becomes smaller than the current window size, initially we maintain a window size of max, infinity max. So yeah, so yeah, if we go if we somehow not go into the loop, so what we will do is we check if the res length is infinity max, then we will return empty. Otherwise we have some values start and res, that because we have like entered this while loop. Yeah, and here as I told you, we decrease the frequency, as we did this for a, we decrease the frequency when we have like have equals to need. So we will do this for till we have equals to need. We will decrease if the same, if the character in this is also present in here, the same condition is there, and it's smaller than the required size. So the size, the frequency is this, required frequency is this. If it is smaller than this, so we increase the have. So yeah, see, this is pretty simple, and we are like moving to the next pointer, left pointer. So yeah, this is the pretty simple code here, and this is pretty simple logic here. We just moving the window next, and decreasing the left pointer and increase the right pointer based on if we find the have equals to need. So yeah, and let me just calculate the time complexity here. So this is n, so let me write here n, and this while loop will run till the window size. So it can be like depend on, so it can also give to n. Yeah, so if we like see here, this can be m plus n. So yeah, so this can be, where it was, yeah, so it can be mx at max, because have, the value I have is the max character in this uh, this frequency of this t. So whatever the max character, so it can be. So this while loop at max run m, and that too will not run for every case. So it will become n plus m, not n into m. So yeah, it will run once for every character here. So yeah, because we are moving the window, so that is why it will become m plus n, not m into n. Yeah, so the overall time complexity, let me write here. It will become n plus m here. So yeah, rest we are not doing anything, and we are like the space complexity will also become m plus n. because this is n and this is m. Yeah, so that's about this video. If you like the video, please like, and also consider subscribing. So let me just tick it, and I will see you in the next video.